Welcome back, my friends. We are starting our unit on the digestive system, Unit 11. In this first part video, we are going to be looking at digestive processes. In future ones, we'll look at what happens in each individual part. But right now, we're just going to look at the kind of general processes involved with digestion. So, a little bit of an overview to start. The alimentary canal, or gastrointestinal tract, otherwise known as the GI tract, its job is to digest and absorb food. That's its job. Pretty simple. The alimentary canal, or GI tract, consists of the mouth, the pharynx, the esophagus, stomach, small intestine, and large intestine. Basically, the tube that goes from your mouth to your anus. You can think of the alimentary canal like this, okay? Or a body like this, really. We are a long tube, hollow in the middle, the alimentary canal, and then this plastic rubbery part, that's our flesh. That's our bones and our skin and our muscle. But this tube, you could run a string down through it from one end to the other end, and it could come out the bottom end without breaking the plastic, without entering the material of the body at all. And you can do that with our digestive tract. Technically, it would be possible to send a probe, a tube, a string, a rope in your mouth, and if you could get it woven all the way through all the twists and turns, it would come out your anus and do no damage if you're very careful and it was smooth and slick and everything. And then you could literally floss your alimentary canal if you wanted to. And the difference is we take this tube and then it gets twisted up in the intestines, maybe expanded out right here would be the stomach, and it'd be expanded out, and then you got the anus on the bottom end. That is the alimentary or canal or GI tract. Now, we have some extra stuff beyond that, things hanging off to the side that are helping out, and we call those accessory digestive organs, things like the teeth and tongue in the mouth, and various glands and things farther in that produce digestive juices and help to regulate and process things like the gallbladder, salivary glands, liver, and pancreas. So here we can just do a quick overview of the various parts of the alimentary canal. We can start with the mouth, going back into the pharynx, down the esophagus, into the stomach, and then the stomach, we can see where it gets into the small intestine. There's three parts, we'll talk about that later, but through the small intestine, into the large intestine, and then down out through the rectum and anus. The accessory structures we can see in this picture, we can see the salivary glands and the teeth and the tongue in the mouth. We can see the liver, the gallbladder, the pancreas down here below, and that's about what we can see in this picture, but it gives you a general overview of them. All right. So let's start taking a look at the processes. The GI tract basically is just a disassembly line. It takes in that food we ingested in big bites and winds up breaking it into small enough pieces that we can get it into our bloodstream. Okay? So nutrients become more absorbable in each step. They get smaller and smaller and converted into absorbable molecules that we can get into our bloodstream as you go through. 6 essential activities that happen in our GI tract. Okay? And this is just an overview, I'll go more into them. Ingestion, propulsion, mechanical digestion, chemical digestion, absorption, and defecation. All right, first one, ingestion, pretty simple, taking food in. Taking a bite, that's it, that's ingestion. You got food into the alimentary canal. Propulsion, which is moving things through that canal, and that includes mainly swallowing, which is getting it back into your pharynx and esophagus, and then down there. And then peristalsis is once it's in the esophagus, everything else that pushes things through the tube. Peristalsis are the waves of contraction and relaxation of the muscles in the organ walls. Like if I stuffed something in here, I don't have anything that's going to work right at the moment, but if I stuffed a little BB in there or something, if I wanted to move it through and it was stuck, I could squeeze behind it, kind of like squeezing out a tube of toothpaste. And if I squeeze behind it, I could literally squeeze that ball in front all the way through. That's what peristalsis is. The smooth muscles around your GI tract act like my fingers and squeeze, but they squeeze just behind whatever it is trying to move through, and that forces it further and further down through the tube until that peristalsis plops it out the other end when you're in the bathroom. Another activity is mechanical digestion. That's where you literally physically break food apart with, say, your teeth, your tongue, or your stomach just churning and smushing the food around. One thing here to kind of show you the difference between the two. The picture on the top is peristalsis. You can see this, and this is like, just pretend a tube, any part of the alimentary canal. And we got a big brown bolus of food in the lumen. The lumen's the empty space in that tube. And we are squeezing right behind it in progressive waves, moving it down in front. Now that's different from segmentation, which happens in the stomach, for instance, where we're taking that food and rather than kind of squishing it down, we got food in there, we kind of squish it back and forth, squish, trying to get it all mixed up. Kind of like if you ever get one of those cold packs that you have to squish up to get it activated. If you get an injury or something, you squish them back and forth. That's more of a mechanical digestion thing, which is segmentation, versus peristalsis, which is propulsion, moving it. Another activity that happens is chemical digestion. That's where we use things like enzymes and acids to break down the food at the chemical level, breaking chemical bonds. Absorption, that's the actual movement of nutrients from the GI tract into the blood or lymph streams. And this is accomplished through, active diffusion, osmosis, active transport stuff. And then finally, anything you couldn't absorb, that leftovers, comes out with the elimination of indigestible solid waste. That's defecation. Your poop, guys, is basically just stuff you ate the day before, generally, plus some bacteria and mucus that was on the inside of your digestive tract. That's it. That's just leftover food, the stuff you didn't want to absorb. All right, this diagram here, guys, shows you the various processes happening in the different organs and structures and the order in which it happens. I would definitely refer back to this later on after you watch this video and do these notes. I'm going to go through what happens in each of these organs throughout the rest of the notes, but this just kind of puts it all together in one nice diagram so you can see where we have mechanical digestion, propulsion, chemical digestion, and what things are being chemical digested in each of those parts. So something to come back to and take a look at, a nice summary slide. All right, so how do we regulate digestion? There are both mechanical and chemical stimuli. Mechanical stimuli are things like stretch receptors that determine that, oh yeah, there's something in the lumen, there's something in the stomach or something in that part of the small intestine. And then of course we have chemical receptors that determine what it is that's in there, what the pH of things are. And that can be controlled extrinsically by the central nervous system, the brain and spinal cord, or intrinsically by local nerve plexus. There's local aggregations of nerves in the digestive tract itself. So here's a nice diagram that shows that we just have, I guess this would probably be a small intestine here, but it could be any part of the alimentary canal. We've got the lumen in gray. Okay, we've got whatever the stimulus is, whether it's a stretch stimulus or a chemical stimulus or osmoreceptors, anything like that, determining if there's stuff in there and then what it is. And the short reflex is the local control. Depending on the stimulus, those nerves, local nerves, may tell you to do some effector, either a smooth muscle or a gland. So you'll secrete something into the lumen to help with digestion of whatever's in there, or you'll squeeze the lumen with a smooth muscle to either do segmentation or propulsion. That's the response. And now those chemoreceptors, osmoreceptors, and mechanoreceptors can also send signals up to the central nervous system, which we call the long reflexes. And those can then override and regulate those local ones if they need to, and have a little more control. Interesting thing though, you guys probably heard about this if you've heard about Pavlov's dogs, right? They ring a bell and give them food, and eventually they could just ring the bell and get the dog to salivate. That was taking advantage of this. They were training in that reflex. The sight, smell, taste, thought of food gets the digestive system moving. Okay, sometimes you're not hungry until you smell something good, then you get hungry, or then you start to salivate, or want that food, because up here, these exterior senses are saying, okay, there's something good, we're going to eat it, let's get things moving, let's get things ready to take in that yummy goodness. And so it gets the whole process started externally there. All right, the peritoneum and the peritoneal cavity. The peritoneum is the serous membrane of the abdominal cavity. We talked about this way back when we talked about membranes in the histology unit. Main function is to lubricate the digestive organs and hold them in place. and allows them to slide past one another because they're moving. There's smooth muscle around all of them. They're always moving to move food through or do segmentation and mechanically digest it. You don't want them rubbing up against each other. You don't want them getting twisted around each other. Some animals have that happen more often than others. You may have heard about that, where their guts turn and they twist and they get stuck. Doesn't happen very often in humans, luckily. One part of this is the mesentery. And you may have already seen this in your cats. If not, you'll see it when you do the dissections. This is the double layer peritoneum that kind of connects all the intestines and things. If you pick up the intestine and kind of hold them out, you'll see the span of tissue with blood vessels and things going through it. And that's its job, is to hold the organs in place and to provide a safe pathway for the vasculature, nerves, and lymph vessels to get to the digestive structures, to pick up the nutrients. Without that, they'd just be flopping around loose and they'd have a real chance of getting messed up. Hepatic portal circulation. Anytime you see hepatic, we're dealing with the liver. So we're talking about circulation into the liver. So remember how usually, we say the blood goes, drops off the nutrients and oxygen in the tissues, and then comes back up through the vena cava to the heart, where it can pick up more oxygen in the lungs, right? We talked about that before. Well, the blood coming out of the digestive system, where it's absorbing these nutrients, doesn't go straight back to the heart. Before it can get to the heart, it goes through hepatic portal circulation and runs into the liver. Okay, so the liver can kind of do a little bit of pre-metabolic processing and storage of stuff before it gets into the rest of your circulation. It can also help take care of some of the toxins and things in there too, before it gets spread further around your body. So that blood takes a slight detour from the intestines to the liver and then on and enters the rest of the circulatory system. Here we can see a nice diagram of kind of the different layers and a kind of standard part of the GI tract. We can see lining the lumen there, we've got the mucosa, and submucosa with some glands in it, and things making mucus and things of that nature. We've got 3 layers of smooth muscle working your way out that help to do that peristalsis and segmentation, squeezing in different directions. We can see lots of blood vessels and lymph vessels and nerves and other glands at various depths. We can see the mesentery off there on the left, kind of giving a pathway for those nerves and arteries and veins to get into the GI tract. So that mucosa, it's the moist epithelial layer that lines the lumen of the alimentary canal. It's what's in contact with the food. So it's got to be able to do a few things. It's got to secrete mucus, which helps to protect that canal so the digestive juices and enzymes don't digest your own alimentary canal. It has to be able to absorb the end products of digestion, so absorb those nutrients at some point. So it's kind of seems conflicting, right? You got to keep the digestive juices from getting to your system, but you want to get the nutrients into your system. So we'll take a look at that, but it needs to do both of those. And it needs to protect against infectious disease. Since it's exposed to the outside world, remember sending the rope through this thing before, we need to be able to make sure that infections don't get into our bloodstream from your digestive system. So all that happens at the mucosa. And that'll do it for this part. From this part onwards, we're going to take a look at the system organ by organ as to move through it and take a look at what's happening in each of those individual parts. See you next time. Thanks. Bye.